Hello, everyone. Welcome to our CATIA Systems Talk. I am Gitana Strazdowski. Today, we will continue one of the most interesting topics, MBSE digital engineering ecosystem. My guest today is our subject matter expert and good friend of mine, Saulius Pavalkis. Integration between tools and disciplines is a major direction of MBSE and digital engineering. In this session, we will continue presenting the SysML model of all integrations covering the MBSE ecosystem, use cases, and integrations maturity. During and after the presentations, you will be able to ask questions to Solus in the chat. For those who didn't have opportunity to see the first part of this thread, I remind you that it was held on the May 30th, and you can find the replay of the video on the MBSE Cyber Systems community. I wish everyone a good time and learning something new. My introduction is finished and now we're ready to start. Solo, the stage is yours.
Thank you, Gitana, for introduction, and thank you for finding time here today. Can you see my screen?
Yes, Solo, I see your screen.
Should I share again to see it correctly in the share service?
Yes, you can try to do this, please.
Okay. Share screen. Okay, now I think it's okay.
Perfect.
Okay, so thank you for finding time for part 2. It is even more things to share here because we will make attention will be on what's new, what's happening, and less on the overall overview. Couple of words, where my background is. So I'm from Kaunas University of Technology, where was my PhD, and I was already working at Magic building this core product, being part of core R&D team as an analyst, and there is my experience, mostly concentrating on MBSE ecosystem and integrations and simulation and standards. Now supporting multiple clients here in US, being as integration director, and still helping adopting the overall solution for MBSE, but now more in a bigger part of the ecosystem and integrates with the digitally integrates with the rest of the design and analysis, and preferably in model based, because then we can agree on meta model on the data types, what we are integrating, and actually automate those integrations. I'm supporting a community, which is OMG and COSI, and also we have our private community, which is MBSE community of experts. Here you see go3ds.com cyber systems, where you can actually ask questions and we post, and you can find like 2-3 posts every day from our clients, consultants, and us, what's happening, including this post will be there. And we try to attend as many events as possible, and you will meet us in COSI IS in a week, actually an international symposium, so please come and discuss what questions you have. So to recap from last time, what is the digital engineering ecosystem? So it consists, based on recent DoD update, Department of Defense update from United States of digital engineering strategy. It consists of tools, workforce, software, networks, and hardware. So this is pretty much what we do. We connect all those points together, and including the workforce, because we try to teach, we have EDU department, which has public trainings, and we do the partner trainings and so on. But most attention is for sure for tools and integrations. Now, where everything is going is pretty much, as you can see here, is system engineering V, right? But when we think it is also virtual, right? Because we want to build virtually before we will actually build the product. So we do it in the pieces, right? We do design virtually, we do system engineering virtually, we do 3D CAD, we do simulate 3D CAD, and we do testing virtually. But what if we will connect all of those together? And then what would happen if that you are changing something in the beginning, you will see impact on that final design, and you can even validate and verify the design virtually and preferably even real time. And this is not all or nothing. This is actually a path to go. So we are going this path, integrating the great tools and solutions we have based on the experience of people which are supporting and building them. So digital thread and then real-time integration, and which gives you feedback loop. From the SO perspective, the SO has a lot of tools and solutions for system engineering that would include, and I will show another view here, will include project management, configuration management, requirement simulation, traceability, digital thread, system architecture, as you can see here, CATIA Magic, right? System behavior simulation, multi-physics simulation with Demola, safety analysis, design disciplines like mechanical, electrical design, and then validation and verification. Now going back to our SysML model of integrations, here you see CATIA Magic, Teamwork plugins, Teamwork Cloud, right? And then here we see updated relations to 3D Experience platform and standalone apps. So this view is from our internal alignment perspective in the company. So we have Power BI, like SSP standard, which we discuss in this presentation. This is coming as a new thing, and you can find this model, you know, and presentation of this model actually in the community post. Here is the community, and here is direct link, so those slides will be shared, and you can copy direct link if you wish. So now in part 2, we will talk about model-based design reviews, which is one of the major scenarios of the application of model-based digital engineering. Then we'll talk about Power BI in connection of one of the integrations like SolidWorks. Then we'll talk about server-side simulation, Internet of Things, and hardware in the loop. Wire harness, which is very good alignment between system engineering and electrical engineering. And we'll show new samples, system virtual validation sample and solution, and cyber system governance for software. So from model-based design reviews, why it is important scenario? Because design reviews, they are done as a formal process to approve a next round of financing, right? So if you pass design review of your product, right, solution, you can expect that maybe some issues will be found, right? But then after review of the design, you will be granted next level of finance, and you can continue working. So this is very important, not technically only gateway and step, but also a very important business step. And it is mostly performed, you know, in the virtual manner, but it's you know, people still gather together, still have PowerPoint, still have data coming from you know, PDFs and Excel. And what we suggest, you know, there is really no limitation on making it digitally already. And we are demonstrating in this scenario how this process can be integrated through 3D Experience platform, through Cameo, CATIA Magic. Then we are delivering system architecture requirements and the high-level design from SysML, and we are integrating with the detailed design, and we have tasks, we have risks, we have gateways, we have checklists where we can upload, where we can collaborate, where we can manage baseline and deliver collaboration on the specific review digitally. Here you see dashboard, which consists of requirements, baseline, traceability, project management, risk management, including requirements. Here we see baseline of the artifacts which we are delivering. Every tab has associated specific app where we can perform a task dedicated for that role. So this process is one of the best examples how we can reuse digital engineering ecosystem like 3D Experience platform for model-based system engineering needs, because we want notifications. We want integration to the design. We want collaboration applications like for 3D mechanical collaborations to review that data. We want to gather and govern baseline of the data review. And we want that it all would be digital and all collaborated between different roles with different dashboards. So this process is actually available. You can find more about it. And every part of this presentation has a link where you can actually see more on this topic, including on this one. I will not go through this whole presentation because, as you can imagine, this would be like more time than we have today. But I can just tell that already like 10 different clients are evaluating and some applying already this process. And this is very promising for the future too. Now, going from that perspective, so we have integration between different disciplines. So one of the disciplines in mechanical engineering, and one of the common used tools for mechanical engineering as also produced by Dassault is SolidWorks. And so how we could align between SolidWorks and CATIA Magic. So there is one way to do it, which would not require actual manual work. Here you have opportunity to commit your project and work, same as with Teamwork Cloud, but with 3D Experience Platform using the concept of Power BI. So Power BI is the ability to even open CATIA Magic and SolidWorks from 3D Experience Platform, load the data, work on the data with the right granularity, commit the data in the team, you can collaborate, and then the data becomes available, and then you can have the digital thread, between system engineering and, in this case, mechanical design and SolidWorks. You can always open this web interface and see what traces to what, on what requirements we are working, but work in the native environment, SolidWorks and CATIA Magic. So here is that scenario, and again, you can read more about that. We have Power BI from CATIA Magic. We have Power BI for SolidWorks. There is dedicated apps like Collaborative Designer for SolidWorks and CATIA Magic. And then we have digital thread between them, app, System Traceability Engineer. Now, how that looks like in action. So here you can see a short video. We have icons, apps to open CATIA Magic. Still, you need to install CATIA Magic separately, but in the future, actually click on that icon, will install CATIA Magic automatically. This is just a way to find it faster and start work faster. And here you can see that the digital thread is already enabled. Here you have traceability from requirements to system architecture to the mechanical design. This is performed here manually by knowing what to implement, what is actually on what part in the SolidWorks we are working, and what is the pretty much system architecture which it needs to implement. And that traceability in any case is needed, right? So just here we will elevate the level of that system traceability from pure requirements to actually models. So then we can know if we change the model, what would happen. So here you see actually we are committing project data from CATIA Magic using Power BI, and we can see projects list. And this looks like Teamwork Cloud. It's actually just alternative for Teamwork Cloud when you work with 3D Experience Platform. Then you are working directly, committing data to 3D Experience Platform. Same works from SolidWorks, and then the data becomes available for trace, for analysis, for the rest of the workflow. Here we see in SolidWorks how that looks like. You see the screen on the right side, that's connection to 3D Experience Platform, ability to load the models, and you see I'm connecting to the 3D Experience Platform. I'm loading the model, same Power BI concept, same way to work. You load the data, you work on the data native app, and then you commit the data to get the rest of the workflow accomplished. So here we see we work with the data, we load the data, and when we are ready, we can upload the data back. You can work on part of the model, you can work on full model, And here we have this full digital thread. Okay, that was Power BI with the SolidWorks and CATIA Magic. And you can see here actually Power BI concept became very popular in our ecosystem. You can find Power BI for scanner, Power BI for control build, Power BI even for Demola, right? Those SolidWorks, Stimulus, and few others, actually quite a lot of others, Cadence, right? Even partners, right? So the AutoCAD, right? We can actually enable smooth collaboration between experts working in different environments through Power BI, integrating data. Now let's switch the gears and let's talk about server-side simulation. This is simulation which we enable SysML, UML, UAF simulation directly in Teamwork Cloud side. What do we get from that? We get ability to run simulations faster, the ability to integrate those simulations because now you don't need to run client-side software to execute the model. You can generate FMU to server-side. You can use web-based simulation interfaces. So how that looks like, here we have architecture of the solution. We see Teamwork Cloud through REST API, and one of the clients is like Cameo Collaborator, another client is Jupyter Labs. And here again is the link in the MBSE community where you can find more about this. How this works, let's see short video. So here we have sample for car brake analysis. And that sample is committed to Teamwork Cloud. So once it is committed to Teamwork Cloud, you can run it from Cameo Collaborator. You can run from Cameo Collaborator directly changing the input values and executing here. And following release, July 2024 refresh one, you will be able to see in Cameo Collaborator even visually diagram simulation. So states, activities, visual drawings will be in Cameo Collaborator, animated visual diagrams. And also we can run the simulation through Jupyter Labs, so you can actually connect to Teamwork Cloud, execute the model, get results, compare results between different other models, connect to other tools, and execute. That's how simulation orchestration is performed and should be performed in the future with other tools. So here we see a web interface running simulations from Cameo Collaborator. And you can actually, in the few, again, July release, this year, July release, we'll have even diagrams simulation inside of the Cameo Collaborator. Okay, and another topic is hardware in the loop. So this year, and actually a few years ago, we spent investigating what are the best methods to make a connection from virtual to real. Right, and this real topic is very big because you have a lot of different hardwares, and we have also a few solutions for that. But let's concentrate on CATIA Magic integration to Internet of Things and hardware in the loop topic. And we already posted a few samples available, but all of those samples are leveraging library of the MQTT connection, where you can, it is lightweight communication protocol, where you can connect, publish and subscribe to specific topics, and that allows you to collaborate with almost unlimited amount of hardwares and softwares in the market. So here, for example, in this sample, we have, again, MQTT standard collaboration communication with Node-RED. Node-RED is low-code connection software. It allows to connect to 5,000 connectors. So you can connect to, let's say, world map where you can plot, some data. You can connect to weather stations. You can connect to data storages, and all of that is coming as a connection just from CATIA Magic through MQTT, running the simulation with the library, which you can download again from the link below. And in this sample, again, we use Node-RED to connect to IoT platform Blink, which allows you to access anywhere in the world data, because then it is like running on the server. And then through the hardware, the hardware is publishing to IoT platform. This is not a must integration. Could be hardware to CATIA Magic directly or somehow else, but we just wanted to have flexible interface here. And as you can see here is the usage of the MQTT library. We have open connection, so where we will specify what the server we are connecting, credentials. Then we have publish. So you publish pretty much on this topic, and that's it. You just choose the topic where you publish. So for example, property name, right? That's the topic, right? And then you have subscribe. Subscribe is to wait for the topic, right? And here we subscribe. Actually, this is the subscribe. So we are sending data to the specific topic. Actually, we are sending topic here to subscribe, and then we get the data back. In case of publish, we are actually sending topic and the data, because we need to publish to specific topic. And that's it. That's how it works. You don't need to be expert on that library implementation, but you just drag those and you get results. And here we have sample, which demonstrates that you can actually read the data of temperature from two sensors connected to hardware. That hardware could be like Arduino, could be ESP, could be Raspberry Pi, could be anything else, And then as a result, you are reading the data to the model, and in the model we have requirements, we have system architecture, just as you would model without any kind of extra, things. As you see, this model is not overcrowded with some kind of mechanical structures to integrate, but it uses that library, those four, actually almost three, opaque behaviors to publish and subscribe to the topics. And that's it. From those topics, that's like properties, you get updates and you send updates. And here we see the two requirements verifications. The requirements verifications performed. Requirements are, in this case, that the difference between sensors are no more than 5%. So if we have equipment, heating equipment, which needs to be like in some boundaries between each other, this tests that, and also that the heat, it reaches the level in the right amount of time. So like how long it will take to heat from 0 to, or like the room temperature to the right amount. So here we see this working this activity diagram where we subscribe and we wait for value. And when the value comes, it goes the cycle back. You see there is no animation. Animation is very fast here because we just want to get the values. And here is that library where you can build. Again, you can download that library, and this library will allow you to communicate with MQTT. MQTT is supported directly by hardware, right? You can connect directly to the hardware through the MQTT server. Here we are using Node-RED in between, which is low-code connection interface, open source. Why we are using it? Because it allows us to have 5,000 connectors to anything else, and also we are using Blink. Why we are using Blink? Because you can access then dashboards remotely from your mobile phone, from somewhere else. And also you can communicate with this IoT software to anywhere in the world, gather data, from example, from the tractors running in your field, and get that data. And not necessarily the data will be consumed by CATIA Magic. You can store that in database, but CATIA Magic can check the architecture real-time, optimizing that. So here we see this dashboard, and this is a Blink specifically IoT solution. Okay, now let's switch to another solution where we have updated project for eVTOL for demonstration of electrical integration and 3D wire harness. In this case, architecture would be that CATIA Magic is actually providing requirements and system architecture, and then all of that is used in the traceability to trace to the electrical 3D design, system design, which is the schematics, And all of that is governed by traceability and baselines. So here we see full picture. So we have requirements, user needs coming from the system architecture. So what we did here is actually my colleague, Pedro. You can find his presentation here under this link. I encourage you to check full presentation. What he did is actually create a system model from beginning to the actual integration to the eVTOL model, but more concentrating on system architecture and how that integration should work from the traceability side, not actually automated generation side, which is also, I think, valuable because in many cases, we are actually not transforming the architecture to something or between the steps, but we are actually recreating another abstraction level in the dedicated tool based on our task and requirements. So that's what is demonstrated here. So we have user needs, we have use cases, and you see they are traced. We have conceptual model where we have high level decomposition. Then we have logical solution architecture. We have logical ports like power control, very important architecture, the smallest architecture, but it's very rich in solution data. And then we have 2D electrical model schematics, right? Where we see the where the wires will go, what would be the actual electrical connectors. When we talk about here logical solution architecture, it includes everything. It includes fluidic interfaces, control interfaces, whatnot, mechanical. Here we have already electrical design, right? So we have concentrated. On the parallel, we would have fluidic and mechanical design, right? But we are demonstrating that and already working on fluidic design. We'll show you a little bit. And then here we have 3D wire harness. So we have 3D wire harness, right? So we have equipment placed in 3D and we have actually wires. And that's how harness is designed, right? So because you need to know how long those cables should be and what type of cables and all the interferences, and so in order to manufacture them in advance and then with the brakes in order to install them correctly, not too long, not too short, right? Just right ones. We can't manufacture on the plane. We do it in advance. That's why we do all this process, and we have it integrated. Here we see already fluidic interfaces, and that's our current job to make this fluidic integration and to show how this will be impacted from system architecture process and changes. You can already see that actually, even right now, even system architecture to have those interfaces, high voltage, low voltage, thermal communication, those interfaces become busy, right? And we have crucial capability, essential capability, ability to filter based on use case or based on interface type, when you can actually communicate architecture and present it correctly, to require stakeholders to manage that architecture, to keep it up to date. Otherwise, there's no way you can manage large architectures. They just become disconnected and stay just as documentation, a snapshot at some time, And here, this capability actually very easy to use and allow you to actually get the most from solution architecture and from MBSE in general. This is one of the enablers of MBSE, this filtering by the legends. And those legends could be automatically extracted, could be manually generated, applying legends items on the required parts and interfaces. Now going to the virtual validation. This is a very big part of system engineering. When we build a product, right, we want to be sure that it is accepted by the users. And again, it's part of the business process. You show the products to someone and they will say, okay, this solution is okay. Okay, how to install this part, which cabin is better, this or that, And we have a solution in Dassault. It's called 3D Excite is the brand, and the app's called Creative Experience, and it can integrate with system engineering, as you can see here, and it does integrate and allows you to run the system architecture in the final stage through the scenarios, through the actual implementation, as if it would be already done, and As you can see here, we are leveraging server-side simulation, web server for simulation to read the simulation data. There's another way to do it through FMU, and you can actually then integrate and run the simulation, clicking the buttons in UI. That could be here, as here in CATIA Magic UI, clicking and running through the process. And in the week, we actually will show that. We'll show that live, in the booth. Please come into the booth in CATIA IS. We'll show this sample, how that sample is made, and we can discuss what that gives for your immediate validation and like user acceptance. So if you have some ideas on system architecture, you can actually validate them today with the users who will need to accept them. So here in this scenario, we are calling the autonomous Uber, and based on the availability, we get one another Uber available, and this is Olympic town where you get those Ubers arrived. And then as you can see, it's not limited just to the, clicking in user interface here in CATIA Magic in SysML. You can actually also click in the 3D environment. You can have 3D glasses, overview what's happening, and also run different scenarios when, for example, the vehicle is actually eVTOL, which we were designing in electrical, from an electrical perspective. Now it is actually mechanical already with the scenarios and can execute and run. Another scenario where we have mission engineering, where we have a mission, we have some events happening and we need to react to those events. We have drone, we have planes, we have radars, we have all collaborations. So mission scenarios executed from CATIA Magic system. Multiphysics is calculated with Dymola running on the platform, is running and calculating parameters. And that shows that we actually can run multiple tools integrated through simulation real time. Would it be 3D? Would it be multiphysics simulation? Would it be robotics simulation? All of that can run and can produce the results, requirements verification results, but also user validation, acceptance of that scenario. You run scenarios, you get acceptance of those scenarios. Okay, now going to the software piece, right? Software is actually a very big part of the current systems. And here what we are releasing in July release will be agile collaboration capability. This is plugin in CATIA Magic where you can mark parts of the requirement model with items from this agile plugin, and those items like epics, as you can see here, capability, feature, story, and based on that you can automate item synchronization to external environments. In this solution case, it is Jira where you get automated this information, and that enables workflow of agile collaboration. Another part of that is actually that you can keep that in trace, right? And one more part of this is actually a little bit different. It is extended capability for code generation. So now, as you know, like last few years, we were working on code generation from the behavior diagrams like states, blocks, ports, properties, and activities in recent releases, right? So a big subset of SysML. And now what we have is ability to actually automatically commit to Git, right? So you have ability to specify where is your software and commit to GitLab, right? Not only to actually generate the code files, but actually automatically put them into repository, and those become synchronized to the model. You can actually do the code change, you can do the model change and update the code. and update also the model. And also traceability is enabled, right? So we can see the traceability from the model to the repository, to the code artifacts directly. Now, how we approach that client engagements. So this is looks good, right? So we have a lot of steps towards virtual twin, towards model-based digital engineering, aligning design, analysis, and system architecture. But so let's say we come with the client together, and then we see the client environment, and the client has like 4 different ecosystems supporting different programs, right? One of them were created for one program, another one for another program. The third one is this organic, which we have in the house. But then they need to decide, okay, which ones we will continue supporting for other programs, which ones are the best. So you need to build almost enterprise architecture for that. What is enterprise architecture? Is that what solution we have now, what solution will be tomorrow, and what is in between, right? So you can actually start building that without a big efforts to learn how does this created, just creating the solution architecture of current stage, so maybe alternative, which if you have in the company, and then building the future stage, right? What should be the solution architecture which we will provide, and that can be in the same project, right? You can drag those. You can actually download our SSML model. You can create your block, like my company solution client digital engineering architecture, drag CATIA Magic, drag 3D experience, show the apps with interfaces, connect them, create external, and then you will find doors and door server actually even in that same project. Create external apps with interfaces, connect them. Those interfaces from CATIA Magic already exist, from server side already exist, from 3D experience platform, related apps already exist, connect them together, show what data flows, and that already gives like big part. As you know, solution architecture is not something, which is, optional. This is the biggest value of model-based system engineering, because it allows you to communicate the decisions and how system works, right? So we can communicate that, and with the item flows, you see dragged, we can help understanding what flows where, right? So that requirements flows between requirements engineering 3D experience platform both ways, right? Through Data Hub, right? To CATIA Magic Rich Client. That's helps a lot, Sure, you can create also activity diagram with swim lanes as those apps to show the exact process, how that will happen. Especially this is needed if you're introducing new connection and you need to actually explain 100 times, okay, that's how it will work, that's how it works. You can deviate, but that's what we support in the organization. So this is what we help, but actually organizations can do by themselves. So to conclude, today we presented, and last time we presented MBSE digital engineering ecosystem towards model-based virtual twin. Why virtual twin? Because it integrates design, analysis, system engineering in a single environment for the continuous engineering. And here you see those presented parts. The ecosystem is bigger, right? You can take a look from last presentation, but we showed JAMA integration, which is one of the most popular integrations in the market, and tools for requirements management. We showed traceability and integration with electrical and 3D wire harness. Again, take a look and request for the project. Then we showed SolidWorks integration through Power BI out of the box through digital thread. We showed design reviews, which is maybe the main use case of how we can align 3D experience platform and CATIA Magic for the model-based digital engineering, hardware in the loop and IoT to connect to multiple devices and get closer, real and virtual, actually connect them together and run scenarios together. SSP for scale simulation. Last time we presented, this will be ability to simulate internal block diagram in another environment like the Mola, 3D experience platform, or even competitors, right? Based on standard from Modelica, and then virtual validation. and cyber system governance for software governance in agile method, and even better code generation from behavior diagrams. So for more information, please visit MBSE community, and this presentation will be available there together with this recording.
Yes, Solo, wow, thanks a lot. So during this session, we learned about 9 or 10 integrations. And you mentioned that JAMA is one of the most popular one. Which others you can identify as a most popular?
Definitely this design review process, which is not single integration, right? But it is alignment of the products in apps, right? In the 3D experience, delivering that virtual model-based design review is crazy popular scenario, right? We have already 10 clients interested, engaging on this scenario, because this elevates from document-based, PowerPoint-based, again, business process. It's not only technical process, right? But business process to get next round of finance to the next level when we can do it virtually, submitting artifacts when it's available, producing them in apps, and tracking everything, issues, risks, and delivering. And that is based on different roles, different dashboards. So I think that's definitely one of the major ones. But also, what we see is like SSP, the scale simulation, will be a next winner, because it's very hard to align simulations and run them in integration. And this SSP will be standard as FMU, same organization, very popular standard FMU. So now we will connect FMUs together and run together. But also those other, like hardware in the loop, I think it's less popular, but it is the way to align your hardware solutions prototypes with system engineering and design, like out of the box, just get it run, gather the data real time. And then virtual validation, with the 3D side creative experience. I mean, if interface is available, why not to run your simulation in integration and then get approval, instead of working for months and maybe years, and then only then noticing that, okay, actually we expected something else.
Okay, I see. And what do you predict for the future integrations? Are we going to have more integrations?
Definitely software is going more and more intense in systems, right? So that will be like a core part. Even right now, R&D is working on some, flexible software-based integrations, which we don't want to mention, until it's available. But AI, we didn't mention AI, right? Some AI will be there, like some copilots, right? Not like intrusive AI, but AI which will tell you, okay, have you thought about those failure points? Have you thought about this material which is normally in this product? Have you thought about this traceability which should exist, but you didn't yet create it between CAD and 3D experience and system architecture and requirements? That will be helper, not kind of in immediate automation, but it will elevate the automatic tasks to next level, so you will be able to concentrate on better design.
Okay. So there will be no short in the work for the for the
Will be more
integration.
work, actually more work, because as you can see here, system engineering is so intense on work. You're connecting the dots, right? You need to be sure that you notice all the possible issues when design will be implemented, that you don't have time even to improve. You have so few system engineers in the world, and there should be like much help for them. But also one more thing to mention is that virtual twin concept. I think it's going better and better, because you can see virtual factory, right? You can see validation of the system in virtual environment. You can see SysML running. You can see detailed design simulated. But to connect all of them together, what we are showing, where we are going, it is the key, because then decision made in one part, how it impacts full cycle. And that's I think will be like a type of the solutions which we will see more and more in the future, as we showed today some of them.
Okay, so I think that we are good, and we got a few thank you for your presentation. It was really broad overview of the integrations. And I believe that in the next sessions of CATIA Systems Talk, maybe we will go deeper into one or the other, the most popular one. But for now, I'm saying thank you, Solo, for your presentation. Thank you again for everyone who were together with us. Please connect to the community. You see the QR code here, and also Saulius will share his slides on the community. So, and in case you have questions, please don't hesitate. You may ask them in the comment session. And now I'm saying goodbye for everyone, and meet you in a month for another CATIA Systems talk.
Thank you,
Thanks a
Gitana.
lot.
Thank you, Gitana. See you